Now, the general thing we're going to be doing is doing systems and solving them, or graphing inequalities when you talk about a system. Now, some of it you can do on the computer or calculator, and you'll definitely want to do it on the calculator, but you might need to do some of these by hand as well. So, start with something simple. X squared plus y squared equals 13, and xy plus 6 equals 0. How would you go about solving this? Okay, solve for y, just do that. So which one? Top or bottom? Okay, so how would you get solve for y? Okay, so we get negative 6 over x. Okay, all we do is, like you're saying, subtract 6 and divide by x. Then what? Okay, substitution. So we can plug this in here. So you have x squared plus, what are you going to square this?
36 over x squared
equals 13. Okay, so multiply by x squared, we're going to get x to the 4th plus 36 equals 13x squared. Now, what restriction do we want to put on here?
Is that like the u equals?
Well, what restrictions? Like, what number do we not want to accept as a valid answer? So x does not equal 0 if we're going with this. Why is that? If anything divided by 0, we have a problem. Remember right here? Okay, so we can say x to the 4th minus 13x squared plus 36 equals 0. Yeah, we can say u equals x squared, so u squared minus 13u plus 36 equals 0. Factor, what multiplies by 36 adds to be negative 13? So u minus 4, u minus 9 equals 0. Therefore, we have x squared minus 4, x squared minus 9 equals 0. Solve that, or factor further. X plus 2, x equals negative minus 2, x minus 3, and x plus 3. So what would be your solution be? Negative 2, 2. Now, we have to plug these in and see if they work. So, if x equals negative 2, negative 2 squared is plus, so we have 4 plus y squared equals 13. So what would y equal? So negative 2, 3, or negative 2, negative 3. For this one, right? Now, if I plug it in here, do they both work?
And where?
So these two, both numbers work here, but do they both work in the bottom one? Because if I plug in negative 2, negative 3, negative 2 times negative 3 is a positive 6 plus 6 equals 0. No. So that goes away. There's the second one. Negative 2 times 3 is negative 6 plus 6 is 0, so that one works. So this works for both of them, so that's one of our solutions. Now, if x equals 2, how would it be different? We have 2, 3, and will both of them work? Which one doesn't work? 2, 3, because 2 times 3 is positive 6. So we've got two solutions. Now let's go over here. 3 and negative 3. So 3, and negative 3, something. So 3, if I plug in 3 here, I get 9. What are the two answers that x 2? 2 or negative 2. And down here,
Sure.
2 or negative 2. Now which ones don't work? What's the second one? Double positive, double negative. So these are my 4 solutions. Well, what do you mean? Well, we're just... Okay. So there were 8 possibilities that worked with the first one, given our values for x. However, only 4 of them actually worked. Now let's consider, what's the shape of all these graphs that we're dealing with? How many solutions could you actually get? So for example, if you're dealing with a circle, say a circle and a hyperbola, how many solutions could you get? Could you have 1 solution? Okay, how would it have to be for 1 solution? So if we did something like, if it was something like that, this one just comes in, touches there. There's an example of 1 solution, right? Or 2 solutions. Right, like that. Or both vertices, yeah. How about 3 solutions?
Like that, and then 1 connecting it.
Okay. So double here and then there. So you can have 3 solutions. 4. Okay. 5. Okay. Yeah, it can't be 5.
Why?
Okay. How could you orient them such that they could get 5? And where could the circle be such that it would touch one of the graphs 5 times? Any combination of 2 graphs 5 times. Can you come up with any? Okay. So how about, say, if you look at our equation, what is this shape? Circle. What is this one? Oh, that's this right here. What is this? Rational, good. So you got a circle and a rational. So you got a circle and a rational. How is rational shaped? Go. Oh, we know it's got like a horizontal vertex thing. So we could do something like this. And this is what it's doing. It's up in here and here. And you get the 4 solutions. So that's how what we generate to get those 4 solutions. Something along those lines. Right? Everybody see it? Okay. And everybody understands how to solve it. In general, fairly simple if you can solve one of them for x or y and substitute it the other. Now, we're also doing some graphing of inequalities. See if I can make one that's interesting. A system of inequalities. Everybody remember how to graph systems of equations, right? Or systems of inequalities? So let's do a simple one that's like an algebra 1-1. Y is less than x plus 1, and y is greater than or equal to 2x plus or minus 3. Okay, everybody know how to graph that? How do you do the first one? Okay, so it's up 1 over 1, and it's going to be a dashed line here. And would you be shading above or below this line? Below. So we'd have all of this shaded for that first one. Okay. Second one.
Down 3.
Okay, starting down 3, and then 1, 2 over 1. Okay, we have a solid line. Above or below this one? Above. So what is shaded by both of them? Okay. So this part right here would be our answer. This area that shades both of them.
I would really need to change that.
Yes. Now, the rest of it is showing your work how you got to that. Is that how you follow that?
Yeah, what would you have to do? Would it be the shaded region?
It would just, the answer would be the dashed here, the solid here, and the shaded region in here. So, now let's mix in some more fun ones. So let's see. X squared plus y squared is less than 25. And y equals a negative x squared, not equals, is less than negative x squared. I should do less than x squared. Okay, so first one we've got is circle, right? Circle radius of 5. Is it a solid or dashed circle? So let's change it to a dashed circle. Radius 5. Now, shading inside or outside? Okay. Typically, if you have a less than, it's going to be shaded in, and way to test it is half.
Plug in 0, 0.
Plug in 0, 0, good. 0 squared plus 0 squared is less than 25. Okay, it has to be in the shaded region, so we know it's all of the inside that's shaded. Okay. Second one. Yes, I know. I'm very skilled with art. So, second one. How do you graph it? Okay. Through the origin, so parabola upside down, 1, 2, 3, 4. Solid or dashed? Okay. So you got doing something like this. It's ugly. Just not as good, so okay. Let's copy the and split. It's such everything. Anyway, there we go. Okay. And then what is shaded by that one? Above or below? Let's plug in 0, 1. 0 squared is greater than 1, 1. No, so 0, 1 is out, so we know this part here. So our answer is that section. Because that's what is shaded by both of them. And notice, if we extended this shading would continue out down here, but the green would stop at the line.
And the answer is the shading, we have to choose colors.
No. I mean, all you have to do is show this part and making sure it's clear that this is the part you're talking about.
Oh, but not to be past the circle?
Yeah, because remember, this is our answer. Our answer is inside the circle and below this line. Interesting thing is when you start doing these with hyperbola. So let's just do a simple hyperbola. Say x minus 1 squared over 4 minus, say, y plus 2 squared over 6 is less than or equal to 1. No. Okay, so where's the center for this?
1, negative 2.
Okay, 1, negative 2. Right there's the center.
No, that's wrong.
1, negative 2.
Fine, 1, negative 2, right there. What if I want to move it over? I'm just going to rewrite that as 2.
Mr. Samuel, where's your education degree?
Okay. I sure want to know.
Why?
Okay, so what's the slope, approximately, of the tangent line, or not, the asymptote? Root 6 over 2, which is approximately what? So we do it with a calculator. $1.23? Okay, so that's about 5/4. $1.23? 2. 1.2? 2. 2. So it's a little less than 5/4, so right there.
I don't think that's accurate.
It's not exactly, but it's close enough. And then where are our vertices going to be? Let's see. 1, 2. Figure them out. Where's the vertices? Okay, where's it at? Is it vertical or horizontal? Horizontal and right and left 2 units. Is this going to be solid or dashed line? Solid. So we know it's coming in here to that point and then going back out. Now, where is the shade of this?
The shading?
The shading of this.
How can you tell, like,
Yeah, let's plug in 0, 0. Right here. Is this true? So 0 minus 1 is?
yeah, 1,
Squared. So we get 1/4 minus
4, 1/3.
2/3. Is it? 2/3, right?
Yeah.
Okay, is that less than or equal to 0, or 1? Yes. Because it's going to be negative. So, which means that all of this out here is shaded.
When you pick a point to plug in,
Yeah.
when you
Asymptotes are not actually part of the graph.
pick a point to plug in, can you not put anything that's on the hyperbola here?
Correct. Because if it's on the, here, let's say, we plugged in this point, which was -1, -2. What do we get when we plug -1, -2 in? -1 minus 1 is -2. -2 squared is?
4.
Yeah, 4 over 4 minus, plug in -2. -2 plus 2 is 0. So this is 0 is less than or equal to 1. So 1 is less than or equal to 1, which means it has to be in the shaded region. But not that you can tell that because it's a solid line. It's in the shaded region. But which side will be shaded? We don't know.
So what about the asymptote?
Okay, asymptotes are valid things because they are not part of the graph. They are guiding for the graph, but they're not part of the graph. In here? Here? Okay? Because remember, when you're doing lines, they're dividing this into basically 2 regions. This part and the part of the graph will. We can,
It's going to be like, on that side, would it be that way on top?
yes, if something out here works, then it would be here and here.
Oh, okay.
Now, you can, of course, you can test it, or you can test it points here and here. Say, okay, they clearly don't work in this case.